Good morning, class. Sorry I can't be there with you today. Today we're going to talk about one-sided and infinite limits. These are special types of limits. The one-sided limits we kind of already talked about yesterday at the very end of class. Today we'll talk about them in a little bit more detail. Okay, let's get started. So from yesterday we saw this function. This was the heaviside function, again quite common in engineering. And you'll see similar functions like this also in pharmaceuticals. I think one of your assignment questions dealt with it. Okay, so we determined from this function that the limit as x goes to 0 of f of x does not exist because the function approaches two different values as it gets to 0. Okay. So let's take a look at the function in question again. So here we go. So as we saw yesterday, as x approaches 0 from the left side, so x approaching 0 from left, left from left, f of x approaches 0. Okay. Up here, as f of x approaches, so as f of x, so not f of x, not f of x, as x approaches 0, so as x approaches 0 from right, f of x approaches 1. So as x approaches 0, the function has two different limits. If I go from the left side, the limit of the function is 0. If I go from the right side, the limit of the function is 1. So this is why we said the function has no limit. Okay? However, it does have limits if we only consider one side of the function. So for example, if we only consider the left side, it does have a limit because it goes to 0. If we only consider this, so if we only consider this, if we only consider the right side, the function also has a limit because, again, if we're ignoring everything on this side, we're ignoring this, and we're only considering this. So from the right side, it has a limit. And similarly, Similarly, if we only consider the left side and ignore this, and can only consider this side, it does have a limit. Okay? Kind of strange, huh? If we ignore certain parts of the function, we can actually have limits. So this is what we call a one-sided limit. Okay? And symbolically, we can write it as follows. The limit as x goes to 0 from the right, okay, and the limit as x goes to 0 from the left. Okay, so this symbol here, plus, this little plus sign means from the right. From the right. Okay, and this symbol here means from the left. Okay. We use the negative and positive signs because if we consider 0, this is like x coming from all the positive values. That's why it's plus from the right. And this is negative because on the left side of 0, everything is negative. Okay, I think that's where the notation comes from. Regardless, that's what we use. So negative means from the left, positive means from the right. Okay. Right. So we redefine the limit as follows. Okay. So the limit as x goes to a of f of x equals L if and only if. This is important. If and only if. So this basically means that all the following conditions must be true. Okay, so the limit exists as x goes to a if and only if the limit going to a from the left side is equal to the limit going to a from the right side. Okay, so that's what this means. This means the limit, so wait, let's rewrite this. Yeah, so the limit of f of x, I guess I could have left it. So limit of f of x as x goes to a from left equals the limit of f of x as x goes to a from the right. Okay, that's how we read this. So basically, if the left side limit is equal to the right side limit, then a limit exists. If the limit does not, so if the left side limit is not the same as the right side limit, then the limit does not exist. Okay, that should make a lot of sense considering the heaviside function here, where the left side limit, that's this one here, left side limit, is not the same as the right side limit, so therefore a limit doesn't exist. But a left side limit does exist, and a right side limit does exist. Okay, so keep that in mind. You can have limits existing, so left and right side limits can exist, but if we consider both of them, that's when we determine whether there actually is a limit or not. Alright, so that's how we redefine the limit. So, here's f of x. Let's go through an example. Here's f of x. Let us determine the following. Ooh, it's a bunch of limits. Okay, so let's determine the limit as x goes to 2 from the left side, as x goes to 2 from the right side, as x goes to 2, then as x goes to 3 from the left side, as x goes to 3 from the right side, and as x goes to 3 in general. Okay, so let's deal with this one first. Okay, so going to 2. So here's 2. I'm going to draw a dotted line here at x equals 2. Okay, there's x equals 2. Okay, as x goes to 2 from the left side, so as we're approaching 2 from this side, okay, as x goes to 2 from this side, notice my function is going towards 4. So this is 4. Okay, so again, as x is going to 2, sorry, I was sneezing, didn't want you guys to hear that. Okay, so as x goes to 2 from the left side, my function goes to 4. Now let's change colors. Okay, now as x goes to 2 from the right side, notice what value does my function go towards? My function is going towards 2. Okay, so again, for the first one, limit as x goes to 2 from the left side, it's going this way. So going this way, it's going towards 4. Okay, so it's going towards 2 from the left, my function is going towards 4. I go towards 2 from the right, my function goes towards 2. So we can say then that the limit of f of x as x goes to 2 does not exist. Does not exist. Okay, hopefully that's clear. Now let's do 3 as x goes to 3. Okay, you guys can probably figure this out on your own, but I will go through it with you anyways. So, as x goes to 3 from the left side, so we're going this way, x going to 3 from the left side. What number does it look like it's going towards? It is going towards this particular point, which is 1. So, as x goes to 3 from the left side, it's going towards 1. Okay. Now, what about x going to 3 from the right side? So as x goes to 3 from the right side, it looks like I am going towards the same number. So limit of f of x going to 3 is equal to 1. Okay. Now, what's the limit of f of x as x goes to 3? Well, both the left side, so left side limit, so this one, left side limit, is the same as the right side limit, so the limit of this is equal to 1. There we go. Now again, contrast that with the limit of f of x as x goes to 2. We have a left side limit, right side limit, but because they're different, the general limit doesn't exist. Okay. Keep that in mind. Left side limit and right side limit can exist, but if they're not the same, then the limit doesn't actually exist. Right. Lots of strange, almost contradictory things. But when you look at the graph, it makes perfect sense, right? Because obviously there's no limit as x goes to 2 in this case because they're not going to the same number. Just keep that in mind. All right. Now, infinite limits. We've seen these before. We just didn't call them infinite limits. We called them asymptotes. Okay. So an infinite limit. Let's determine the following. Determine the limit of 1 over x squared as x goes to 0. Oops. This is an infinite limit. Okay. And I will show you using Desmos. There we go. So my function was 1 over x squared. There we go. And we're going towards 0. As you can see, my function. As we get closer and closer to 0, my number gets bigger and bigger. Okay. And it's going to get really big. It's going to get really big as you get close to 0. That should make perfect sense because if I take, as x gets smaller and smaller, like for example, I don't know, so x equals 0.001, then you'll get 1 over 0.001 squared, which is 1 over 0.000001, which is going to be a really big number. This is like 1, 2, 3, 4, 5, so like 100,000. There we go. So as x gets smaller and smaller, the function gets bigger and bigger. Okay, and we can make the function as big as we want as long as we keep making x closer and closer to 0. We can't make x equal to 0 because, as you can see here, if I make x equal to 0, I get a division by 0, which does not actually work. So for this situation, basically just say, okay, as x goes to 0, the limit is equal to infinity. Okay, so infinity is not really a number; it's sort of an expression. Okay, so infinite limit. Limit goes to infinity. Okay, and a similar thing can be said if it's going towards negative infinity. So, for example, if I had this limit as x goes to 0 of 1 or negative 1 over x squared, this is going to be negative infinity because it's basically the exact same situation as this, but it's just negative. So it is possible to have a positively infinity limit and a negatively infinite limit. Okay, and again, it just depends on the shape of the graph. So if the graph is going infinitely up like this, that's an infinite limit, and if the graph is going down like this, that's an infinite negative limit. Okay, basically, infinite limits occur at these points where there are asymptotes. So whenever an asymptote appears, you'll probably see an infinite limit. No, you will see an infinite limit. Not probably, you will see an infinite limit. So asymptotes equals infinite limit. That makes a lot of sense though, because when you see the graph of an asymptote, that's what it is. It's going towards either positive infinity or negative infinity. Alright, let's go through an example. So, find the limit of x going to 3 from the right side, and the limit as x goes to 3 from the left side of this particular function. Okay. You can sort of do this by hand, or you can graph it. Okay. If you do it by hand, evaluate the function at, let's say, x equals 3.001 and x equals 2.999. Okay. Right. So the first one, 3.001, so this is x approaching 3 from the right side because 3.001 is to the right of 3. So from the right side, we get the following. So from right side. And again, this is coming from the right side because 3.001 is on the right of 3. So this would be 3.001 minus 3, this is 0.001. This is going to be 200. Okay, so it looks like it's getting bigger. From the other side, so from left, get the following. 2 over, this is the opposite, this is 0.001, but negative, so this is negative 200. So it looks like from the left side, it's getting really, really small. It's getting a really large negative number. From the right side, it's like it's getting a very large positive number. So I can basically say, I guess, this. So it looks like the limit as x goes to 3 from the right side of our function f of x, this is going to be positive infinity. And from the left side, as x goes to 3 from the left of f of x, our function is going to go towards negative infinity. That's what it looks like, at least. So let's graph it and find out. Alright, so 2 divided by x minus 3, and voila! There it goes. So as you can, so I'll just put x equals 3 down. So as x equals 3, that's my asymptote. As you can see, as I approach 3 from the left, x is going negative. As I approach 3 from the right, f of x is going positive. So what we calculated was correct. Okay. Okay. Let's try another example. Alright, find the limit of tan x and limit of tan x. One as we go pi over 2 from the left side, and the other pi over 2 from the right side. Let's just graph this. Well, actually, I shouldn't say that. Your textbook doesn't graph it right away. Your textbook says the following. Tan x is equal to sine x over cos x. So hopefully you guys remember this from trig identities in pre-calculus 12. But tangent is really just sine over cos. Okay. So what does this tell us? This tells us that cos x cannot be equal to 0. Okay. And if you guys remember from pre-calculus 12, cos x is equal to 0 whenever at n pi over 2. Okay. So basically whenever at every 90 degrees, cosine of x is 0. Okay. Good. So this basically means that at pi over 2, we're going to have sine x over 0. So this means that these limits are going to be infinite in some way, whether positive or negative infinity. Okay. And we can just graph this. Okay. If you don't want to graph it, then we pick a number that's on the left side of pi over 2 and pick a number on the right side of pi over 2 and calculate it. But we'll just graph it for a simplicity's sake. Alright, so tangent x. Okay, that's crazy. I'm going to change this to steps of pi. Yeah, there we go. That looks better. And let's zoom in. There we go. There's pi over 2. So it looks like, let's go, x equals pi over 2. There we go. Let's change the color. There we go. Easier to see now. Okay, so there's x equals pi over 2. As we approach it from the left side, it looks like it's going towards positive infinity. And as we approach it from the right side, it looks like it's going towards negative infinity. So we can just what we can say. So this limit, let's highlight it. This limit is positive infinity, and this limit is negative infinity. And we just pull that straight from the graph. Okay. And if you don't have graphing software, again, just pick a number that's close to pi over 2 on the left side, and pick a number that's close to pi over 2 on the right side. Just calculate it and see what numbers you get. Okay. All right, so there we go. So to recap, left side and right side limits can exist, but a limit only exists, only exists if, I forgot to put an assignment on here. The limit only exists if both left side and right side exist. Okay. So let me recap that. Okay, so limit exists. This is if and only if left side limit equals right side limit. Right side limit. There we go. Alright. Now, I unfortunately did not bring my textbook home with me. So hopefully I remember what I actually assigned you. Alright. It'll be, the sub will give you the assignment or the assignment. Alright, so good luck with it. I'll give you guys a quiz in the second half of the double, so be prepared. Be prepared. If you have any questions, don't be afraid to ask me when you see me again tomorrow. Alright, good luck.